So let's solve another problem from the electronics. So the problem states that a Zener diode whose rating is given as 10 volt 2 watt and a normal diode turn-on voltage is 0.7 volt are connected in a circuit as shown in the figure. The voltage drop VL across the 2 kilo ohm resistance is. So we need to find the voltage drop, that is this VL. We need to find the voltage drop VL across these two resistors, right? So one of the important specification is the Zener voltage rating or the Zener diode rating, which is given as 10 volt. So if an voltage is if the voltage, let's say this point is A and this point is B. So if the voltage at the point A is greater than 10 volt, then only the Zener diode starts operating. Otherwise, it will be an open circuit into branch. So first we need to find out that is that voltage across AB is greater than 10 volt or not. For doing it, we will use the Kirchhoff's law. If I is the current over here, so we can directly write that 20 minus 0.5 I minus 1 into I minus 2 into I equal to, and this is that for diode it will be 0.7, right? So equal to 0. So it will be 19.3 minus 3.5 is 3.5 I equal to 0. So I will be 19.3 by 3.5, right? Milliampere. Okay. So let us find the voltage VAB. So VAB can be written as 20 minus I into 0.5. Clear? So 20 minus I is 19.3 by 3.5 into 0.5. So it's 7. So it is, so this is much greater than 10. So the Zener diode will turn off and will give a constant voltage of 10 volt across this 2 point A and B, right? So next is to find the current flowing across this loop of the branch. We can easily find it, right? So it will be 10 minus, if is IL is the current, if IL is the current, then 10 minus IL into 1 minus 0.7 minus 2 into IL equal to 0. 9.3 minus 3 IL equal to 0. So IL will be 3.1 milliampere, right? So the VL can be easily found out from here. So it will be IL into 2 kilo ohm. So it will be 6.2 volt. So our answer for this is 6.2 volt. So it is round up to 1 places of decimal. So it is 6.2 volt. Okay. So hope it is clear for everyone. So thank you.